Next, the myofibril. This little parenthetical aside, each myofibril is a series of sarcomeres. So a sarcomere, guys, is worth knowing. A sarcomere is the smallest contractile unit of a muscle cell. So this is it's the individual sarcomeres that are doing the actual contraction. So the whole cell scrunches up like a tiny accordion. So it's the sarcomeres that are the smallest contracting units of the cell. So a myofibril is a series of sarcomeres. One, and a second, and a third, so you've got a whole row of sarcomere, 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 making up each myofibril within the whole muscle cell. So, one sarcomere is limited by a Z disc at each end. So this is a Z disc. This is a Z disc right here. So, the Z disc would represent one end or the other end of the sarcomere. So the next sarcomere will continue from this. So the Z disc actually links sarcomeres together. The next sarcomere would extend from this side of the Z disc. So, let's see, the M line is what we see in the center of the sarcomere. So the Z disc is this waffle-shaped, or like what we call it, ridge potato chip look to the Z disc. It's a large sheet of protein. We're only seeing a little piece of the Z disc. The Z disc is huge. The Z disc expands this way, and runs throughout the entire interior of the muscle cell. So you have this huge Z disc here, huge Z disc here. You have the next sarcomere, huge Z disc, and so on. So the Z disc extends to the inside edge of the sarcolemma. So it's a huge sheet of protein. Another huge sheet of protein. The M line, however, is a very small sheet of protein that's only found as part of the sarcomere. So this extends to other sarcomeres, extends out to other sarcomeres. This is unique to just this one sarcomere. It's a very small sheet of protein. And what it does is hold the thick myofilaments together. So you've got a bundle of thick myofilaments. 1, 2, 3, 4, etc. here, all held together in the center by an M line. M actually does stand for middle, by the way, in this context. So, let's see. So the thin myofilaments are these red, green, and yellow filaments here. So the protein molecules making up one thick myofilament are called myosin. So sometimes you see a thick myofilament called a myosin myofilament for that reason. A couple of hundred myosin molecules linked together to form one thick myofilament. Thin myofilaments are smaller in diameter, actually measurably smaller in diameter, but they're composed of 3 distinct proteins. So the red proteins are actin, A-C-T-I-N, actin. Each green protein is called troponin, T-R-O-P-O-N-I-N. And the yellow strand-like protein is called tropomyosin. So red actin, green troponin, and yellow tropomyosin. You need all 3 of these for proper contraction of the sarcomere. We're not going to get into the physiology of that in here. We'll save that for lecture class, the actual contractile action that takes place. What does happen is that the myosin molecules of a thick myofilament have these little side heads. They're actually called myosin heads here. And in the relaxed state, this would in fact be a relaxed sarcomere. In the relaxed state, there's a large gap between the thin myofilaments. So we've got a group of thin myofilaments attached to this Z disc, a group of thin myofilaments attached to that Z disc. And then there's a large gap in the center of the sarcomere. That's called the H zone. And again, the M line is the centerpiece of the H zone. All right, so we have during contraction, what happens during relaxation rather, there's no connection between the myosin heads, these things here, no connection between the myosin heads and the thin myofilaments. They're separated from each other. During contraction, the myosin heads join to the thin myofilaments. So contraction requires linkage. It's called a cross bridge formation between the myosin heads and the thin myofilaments. So the myosin heads, they're not angled properly. They should be angled toward the Z disc. All these myosin heads should be bent toward the Z disc. All of these should be bent that way. That's in the relaxed state. They're all angled like so. During contraction, what do? The myosin heads link to the thin myofilaments, and then they bend inward toward the center, toward the M line. So you get this happening in contraction. The thin myofilament being pulled in toward the M line. Problem. Fully contracted sarcomere, the thin myofilaments actually hit the M line. So this is as far as it'll go. So this gap in here is a mistake in this cheaply made, very, very expensive model. So they should go all the way in to touch the M line. Okay, so fully contracted, there is no more H zone at all. So here is an obvious H zone, this gap right there. Fully contracted, the H zone completely disappears. The thin myofilaments smack up against the M line protein sheet. Now, do we have anything else here we can talk about? Yes. In this relaxed state, you can actually see an A band. So the area of the H zone right here, the area of the H zone, we just have the visible thick myofilaments. And then we've got the thin myofilaments right here, thin myofilaments. You have another set of these over here. So you have this group of thin myofilaments. Imagine another group of myofilaments sticking out this way. That would be an I band right there. So I band, actually the I band would be to here. So the I band stops at the thick myofilaments. So Z disc is in the center of an I band, thin myofilaments extending from both sides, and the I band stops when you get to the thick myofilaments of this sarcomere, and you get to the thick myofilaments of the next sarcomere. So that's our I band. The A band would be the entire thick myofilament bundle. The width of the A band is all of that exposed there in the center, from one end to the other end of the thick myofilament bundle. That's the A band. Okay, so this is the complete A band right there. This is the H zone portion of the A band. The next I band would start here. A band is finally over at this point and goes to here. Overlaps into the next sarcomere until we hit the thick myofilaments there. So it's I band, A band, I band, A band, all the way along the entire length of the myofibril. Anything else worth noting here? Think what else? Any questions?